Good afternoon, viewers. Today we have another interesting question to tackle in chemistry, and that is our practice question number 4. Today we are looking at balancing of chemical equation. We have a challenging problem here, but very easy to solve. We should use mathematical method to balance the equation below, which means there are other methods that can be used to balance chemical equations. But here specifically, we are told to use the mathematical method. Now, in the reaction, potassium tetrazool manganate 7 reacting with hydrochloric acid to give us four products: potassium chloride, manganese 2 chloride, water, and chlorine gas. Now, we are told to balance. If you take a look at it, all the state symbols are properly imputed. Now, to solve this problem, solution, I want to solve the problem. To solve this problem, let's start. We'll start by step 1. And what is the step 1 I want to look at? Assign alphabet to both reactants and product to serve as the number of moles. In that case, writing the equation back, we assign A reactant B to form product C, product D, product E, and product F. So, writing the equation back, we now have A, K, M, N, O4 plus B, H, C, L to form C, K, C, L plus D, M, N, Cl2 plus EH2O plus FCl2. This is what you have now. Now, if you take a look at it, all the alphabets represent the number of moles of both the reactants and the product. Next, we now bring down the atoms reacting in the entire reaction. The atoms reacting. The atoms that are present in the reactants and in the product. So we have this now. So the atoms present in this particular reaction now, we have the first atom here is potassium. So I have potassium. The next atom is manganese. We have oxygen. We have hydrogen here. And we have the final one, fluorine. Now, what next? Let's take a look at K. In the reactant side, where is K present? K is present in A, and we have one atom of K in A. So I will say A, meaning one potassium in A, reactant A. On the product side, I have potassium in the product in C. So I have one potassium here. So A is equal to C as my equation 1. Manganese also appears in the first reactant A here. 1 manganese. So I'll come here, A, 1 manganese in A is equal to, on the product side, I have manganese in D. So I have equal to D. That is my equation number 2. Oxygen appears here in A, but here I have 4 oxygen atoms in A. So therefore, I will say for oxygen, I have 4A, and that is equal to oxygen on the product side appears only in E, 1 atom of oxygen. So I have E. It becomes my equation 3. And for equation 4, I have hydrogen. See hydrogen. Hydrogen appears in B. one atom of hydrogen. So I will say B equal to, I will come to the product side. On the product side, hydrogen occurs only in E. Two hydrogen atoms here. So I have 2E. This is my equation 4. And finally, for chlorine, chlorine occurs in reactant B. I have one chlorine atom. So I have B will now be equal to, when you come to the product side, there is chlorine in C, chlorine in D, and chlorine in F. In C, we have one chlorine atom, so I have C plus. In D, I have two chlorine atoms, so I have plus 2D plus. In F, two chlorine atoms, so I have plus 2F. That is my equation number 5. Now, let's get the value of A, B, C, D, E, and F quickly. To get the values, we'll begin to look at the respective equations. Let's start with equation 1. In equation 1, in equation number 1, we have that A is equal to C. A is equal to C. And if you look at it very well, for potassium, in A we have 1, in C we have 1. So my A is 1 and my C is also equal to 1. So therefore, we have A as equal to 1, we have C as equal to 1. In equation 2, in equation 2, in equation 2, we have that A is equal to D. So I have A equal to D. My A manganese 1 here. In A, my manganese is 1, and in D, where manganese is present, I also have 1 manganese. So A is equal to D. It means that D will be equal to 1. I come here and my D is equal to 1. The next, in equation 3. In equation 3. In equation number 3, we have 4A is equal to E. So I have 4A equal to E. And remember, A is equal to 1. So I have 4 times 1 equal to E. So my E is equal to 4. So therefore, E is equal to 4. And we go to equation number 4. In equation 4, in equation 4, we have that B is equal to 2E. B is equal to 2E. And we already have the value of E as 4. So my B now will be equal to 2 times 4. And that is equal to 8. Therefore, B is equal to 8. So my B is equal to 8. What is left now? The last equation, we have B in equation 5. In equation 5, we have that B is equal to C plus 2D plus 2F. Now we impute the values one after the other. Imputing the values one after the other, we already have the value of B here. Our B here, if you look at it, is 8. So I have 8 is equal to C is 1. Our C is 1 plus 2 times our D. Our D is 1 plus 2F. So we have 8 equal to 2 times 1 is 2, 1 plus 2 plus 2F. So we have it that 8 is equal to 3 plus 2F plus 2F. 3 crossing over, it becomes 8 minus 3 equal to 2F. So we have 5 as equal to 2F. Therefore, F is equal to 5 all over 2. Now we've gotten all the values. We've gotten the values of A, B, C, D, E, and F. Now what we do next is to bring these values back into the equation. So to bring those values back into the equation, for my A, 1, so I have K, M, N, O, 4, plus. For my B, I have B as 8. So I'll have 8HCl to form. For my C is 1, so I have KCl plus I have my D. The value of D is 1, so I have MnCl2 plus my E. I have my E as we have E as where is it? The value of E 4. So I have 4H2O then plus my F 5 over 2. So I have 5 all over 2Cl2. But now this equation cannot be assumed complete or balanced because we have a fraction here. Let's take away the fraction. So to remove this fraction here, we multiply this whole equation by 2. So we multiply it by 2 times 2. So if we multiply the entire equation by 2, I will now have 2k MnO4 plus 16HCl to form 2KCl plus 2MnCl2 plus 2 times 4 is 8H2O plus 2 cancel out this 2, I have 5Cl2. What we have here now is a balanced equation. Now let's cross-check if this equation is truly balanced by taking a look at the number of atoms on both reactant and product side. So here I have 2. For potassium here, I have potassium here as equal to 2. On the product side, potassium equal to 2. Potassium equal to 2. Manganese. Manganese on the reactant side is also equal to 2. Here, manganese on the product side is also equal to 2. The next, oxygen. Oxygen here is equal to 4 times 2. That is 8. So oxygen here is 8. While oxygen here also on the product side, here we have 8 oxygen. The next atom is hydrogen. Hydrogen here is equal to 16 hydrogen atoms. On the product side, hydrogen is also equal to 2 times 8, 16. So 16 hydrogen. And finally for chlorine, chlorine atom here on the product reactant side is 16. So I have 16 here. While on this other side, chlorine H, I have 2 chlorine here. Then here I have 2 here. Then here I have 2 times 2, which is 4. So 2 plus 4, 6. While here I have 2 times 5, 10. So 10 plus 6, that is 16. So chlorine is equal to 16. So this is the balanced chemical equation for that particular problem. Balancing it using the mathematical method. So with this, I believe the solving balancing chemical equation using the mathematical equation cannot be a thing of disturbance to you because you can see how easy and simple it is. Though it is kind of an extended explanation, but if you calm down and watch the video over and over, I believe you will grasp it. It will be gotten. So I hope this video is meeting you or is reaching you at the best state of mind. Enjoy yourself, relax, and get the best out of this video until we meet again in our next episode. Thank you very much and bye bye.